Alright, welcome to video number 10. We're going to be talking about conservation of energy yet again. So let's say you have an object here moving along. Let's call this M1, let's call this M2. M2 is at rest, so right now the total energy would be 1/2 mass 1 velocity squared, initial velocity. Then after the collision, let's say the two masses combined somehow, m, and it is moving at a new velocity. Let's call it velocity final. So therefore, 1/2 mass 1 velocity would have to equal and then if you know the masses, the initial velocity, you would be able to find out the ending velocity, but that's not important right now because we're going to see how we can apply this to the problem. So if you remember the problem from last video, we had two particles. A and B, initial velocity here. So we want to show which of the following equations, there's a bunch of equations here, could be used to find R minimum. And this would be the distance. So we're going to have to use kinetic energy, which in this case would be 1 mass velocity initial squared. And then, however, there's also something else we have to take into consider, which would be the potential energy of the system, which would be, it's like this. We know where this is a placeholder for a constant, which is positive, and then R squared, we're going to take 2D and put that in. So that would be 4D squared. So here we would have to have the placeholder constant plus over 4D squared plus the initial kinetic energy would equal to, we would want to have the distance, which is R2 minimum, since we are trying to find that, the placeholder plus, since the masses are now combined, it would just be and this would be the answer. And that would be